Now we're ready to step up and fill in the structure for a backpack class. What this is going to store is, this will be linked to your player. Your player will have a backpack, and it's going to store how many item slots do you have, and what items are in that backpack. So, also we're going to need to have some way to add and remove items from your pack when they're used or gathered. So first thing I'm going to add is public item max, and this will allow you to actually change this later on. A lot of games have features where you can increase your backpack slots by a desired amount, or you find a special item that's a large backpack instead of a small backpack and it has more slots. This gives you some flexibility here. So for now I'm just going to use it as sort of a limiter, and I'm just going to set it to 10 slots, and that's 0 base, so 0 through 9 is 10 values. So I'm just sort of hard coding a value for my number of inventory slots. I'll set a little note here. Say number of inventory slots. And next up, we need a list of the items that are stored in the backpack. So we're going to say public items as a new list of, and the type that we want to store in this items list is copies of our item class. And that's really all we need to get this guy rolling. But now we're going to have some sort of routine to add and subtract items from that. So this is where it gets a little trickier, because we need to track the count of items in the slots and whether they're stackable and things like that. So I'm going to say public sub add, whoops, you didn't see that, new item as, well, it's going to be an item class. That's what we're storing in here. So we're going to use this to add a new item of our desired type to this list. So the first thing we want to check is if the item count is less than or equal to the maximum number of items, then then perform an addition. Otherwise, you're going to have some sort of overflow routine. In this case, I'm just going to ignore it. If we don't have space in our backpack, then simply don't add it. So I'm going to say if items.count is less than or equal to the item max, and you can use this for picking up items, then so nothing outside of that, it'll just skip over the add sub and ignore the item if the backpack can no longer hold items. So then what we want to do is actually cycle through our list of items and check and see if the item name already exists in there. So if we already have a heal weed in there or a red potion or something, and it's stackable, then add it to the stack instead of creating a new stack. So we can say, excuse me, if actually, I'm going to create a loop here. I got to loop through these. So I'm going to say for each I as item in our list of items. So I'm going to say items. And in this loop, we'll check and see if the name of the item we're picking up already exists. So I'll say if item I.name equals new item dot name. That's referencing the item we're passing through the parameter here. So we're adding a new item to the backpack possibly. Then go ahead and check if the item is stackable. So we'll say if I dot is stackable equals true, and if the item count is less than 16, then, okay, now let me, before I continue here, I should explain what I'm doing here. This is something I'm using. You might want to add this as another variable up here. I'm using this as a limiter. So it's saying you cannot have a stack of more than 16 items. You can have all sorts of stacks. You might even define on the item type itself whether the item can be stacked 64 times, like, you know, sort of a standard Minecraft sort of stack, or if it could be stacked, you know, 10 times, you know, whatever you choose for your game you could use. I'm just setting a static value of 16 here because I don't want stacks of any more than 16. Why? I don't know. I just sort of picked that arbitrarily. That just shows you how to limit your stack count. Completely up to you. You could even leave it out if you don't want a limit on items. I think it's logical to have some sort of limitation on items. You know, I mean, I always thought it was kind of funny that you could store thousands and thousands of items in your backpack. Maybe it's a bag of holding or something. Yay! So, if the item exists, and if it's stackable, and if the count of that item is less than 16, then let's go ahead and add a new one to the stack. So I'm going to say I.count plus equals 1. So I just incremented the stack count by 1. And at that point, if the item has been updated or added to the inventory, we're probably going to want to exit the sub. We don't want it to continue processing item data if it's already updated the item. Let's add an else condition here, because, you know, maybe the item was found, but maybe it's not stackable. So we're going to want a new copy of the item. You know, maybe you found another longsword, and, you know, swords are not stackable, so we want to add it to a new slot. We're going to say else items.add and add the new item. Okay, again, the inventory has been updated, so we do not want to continue processing at this point. Let's exit the sub. Alright, now, so what happens if, you know, the item did not exist in the backpack, and, you know, we want to add a brand new item? Well, as long as this is still true and our backpack is not full, there's no reason we shouldn't be able to add that item. So let's go outside of our loop here, because we're no longer looping through the items. The item was not found in a stack or anywhere else in the backpack, so we're just going to say down here items.add and the new item. Alright, so now we've created a method for adding new items to our backpack. Now, what if we want to remove an item? Well, that's a little easier. We can just reference the item that is in our backpack, and if it's a stacked item, then we can remove, you know, we can decrement the value of that count, and if it, you know, if the count is greater than 0, we can do that. If it's less than 0, then just remove it altogether. So I'm going to create a new public sub, and I'm just going to call this one remove, and I'm going to pass the item ID as an item. Okay, so I'm going to say if the items dot item, referencing a specific item, and we're just going to tie it directly to the item itself. or the copy of that item, and grab the index of that item in the list and remove it directly instead of looping through the list, because if you loop through a list you can't remove items while you're scanning for them. So say items dot index of the item ID dot count is greater than 0, then do something. Okay, so I'm referencing a specific item in the list, and what is that item? It's the index of this item here. So whatever item I passed through this parameter, it's going to look for a copy of that item in my items list and remove it, or decrement the count value if that's the method I'm using. So once I've checked to see if the count is greater than 0, so if that's true, that means that we have a stack of items and we just want to remove an item from that stack. We'll say items dot item dot, I'm sorry, not dot, items dot index of the item ID. And again, I'm referencing dot count, and this time I'm going to subtract 1 from that stack. Okay, so I did the exact same thing here. I referenced a specific item by its index value in the list, and I checked the count value of that and decided to decrement it. So what if we checked the item was there and there was no count? Well, let's remove it altogether then. So we'll say else items dot remove at, and what this does is allows us to probe the list for a specific index number and remove that from the list at that index number. So again, we're going to reference the index of item ID. So we'll say items dot index of and item ID. And that's pretty much all there is for the backpack class. We have a structure. Whoop, my cat's playing the keyboard. Nice. We have a method to add and remove items, and we store a list of the items, and we have a max number of items or item slots in that backpack. So I'm going to go ahead and save that.